All right, this is Mr. Gillum, and today we're going to learn a little bit more about the distributive property and combining like terms. So we're going to actually do the distributive property and combine like terms at the same time. Now, like terms is an important thing, and when I say like terms, it's important that you know what I mean. When I say like terms, it means they have to have the exact same variable part. So for instance, an x, a 2x, and a 3y aren't allowed to go together to make 5xy. Okay, that's not allowed to happen. The variable part has to be exactly the same. Okay, even if it was 2x squared plus 2x, those are not exactly the same. One has an x squared and one has an x, and so those are two different like terms. Those are not the same as 4x to the third. Okay, that's not how it works. The variable, anything around the variable besides the coefficient is important to the variable. Okay, so each term is separated by an addition and subtraction sign. This we know. So if I had 3x plus 2y plus 4, there would be two addition signs, but there would be three terms: 3x, 2y, and 4. I guess it's a good opportunity to review some other vocabulary as well. 3 and 2 would be coefficients. 3 specifically would be the leading coefficient. 4 would be a constant. Okay? Now, the distributive property, if you remember, is when we take that number in front of the parentheses and we multiply it times both parts inside the parentheses. 2 times x is 2x, and 2 times 2 is 4. All right? So that's what we're going to do today, but we're also going to combine like terms. So let's start with just the distributive property. Okay, I have two examples here, and we've been practicing using the distributive property to take the greatest common factor out of the parentheses as well as multiply it through the parentheses. So let's do it with multiplying through to begin. So 3 times 2x would be 6x, and 3 times positive 3 would be 9. So 6x plus 9, that would be an equivalent way to write 3 times the quantity, 2x plus 3. And we practiced this, so you probably are getting pretty good at that. Again, 4 times 3 and 4 times 5x. 4 times 3 is 12. 4 times 5x is 20x. Now, this is something that may be new to you. There is a certain order that we want to write each term in. And so any terms with a variable always like to come first. And any terms that are a constant term like to go last. So the best answer for this example would be 20x plus 12. Now, the reason I can switch the order, and I know we've been talking about order of operations for a while, is because the commutative property says, and we haven't talked about the commutative property yet, but we all know hopefully that 2 plus 3 is the same as 3 plus 2. Now that doesn't work for every operation, but for addition it does work. So we try to write our terms in order. Anything with a variable we write first, each term in alphabetical order, and then finally the last thing is the constant. But there is a little added step of difficulty here. This time we have two sets of parentheses. And so what I notice is that I have a coefficient in front of the first set. And so what I'm going to do is I'm going to start this using order of operations. Now what I notice is there is an operation inside these parentheses here, and there is an operation inside these parentheses here. However, an x and a y cannot be squished together. These are not like terms, so they have to stay separate. So what I'm going to do is I'm going to distribute this 2 to both parts. 2 times 3x is 6x, and 2 times 2y is 4y. Now, because there's still an operation in the parentheses, I'm not allowed just to drop the parentheses off. I also don't see a number or a coefficient in front of the parentheses, but there really is one if I want there to be. I know that if I multiply 1 times everything in the parentheses, they'll still be the same. And this is going to be very important when we start using subtraction, because then we need to change some signs around as well. So what we're going to do right now is we're just going to think of there as being a 1 in front of the parentheses. Because if I threw a 1 in there and I multiplied it by 2y plus 5x, nothing will change. But I can use the distributive property to get rid of those parentheses. So I know 1 times 2y is 2y, and 1 times 5x is 5x. All right, and as I use the distributive property, you'll notice that I don't have parentheses anymore. So I do have a pair of like terms here though. I have 6x's over here and 5x's over here. Together they make 11x. I also have these like terms, 4y's and 2y's. Together they make 6y's. Now, I like the order to be in alphabetical order with the constants at the end. In this case, x does come before y in the alphabet, so I like the way my answer looks. Let's take a look at another one. This time I do have a coefficient in front of the parentheses on both parts. Now looking inside the parentheses, I see a 3x and a constant. I see a 2y and a constant. Unfortunately, those cannot be squished together. They are not called like terms. Their variable parts are not exactly the same. So unfortunately, I'm not allowed to just ignore the parentheses this time. But because I do have a coefficient in front, I can use a distributive property to get rid of those parentheses. So 6 times 3x is 8x, 18x. 6 times 1 is 6. Same way here. I have that coefficient. Now, if there's no coefficient there, we can always pretend that it's 1 and then multiply. But again, there's a reason we do that, because not always is this going to be a plus when we go into math in later years. But for now, it is a plus, and so I'm just going to take this positive 4, this 4 times 2y. I know that makes 8y, and 4 times 3 is 12. Now I'm looking to see if there's any like terms, things that can go together. Now, I see a variable part here of 18x, but I don't see any other x variables. So 18x has to be its own term. I also see and 8y. Now I skipped the 6's and the 12's because those are both constants, and we called those like terms as well. And what I notice is this 8y doesn't have any other parts that match him, so we're going to add the 8y on, and we're not allowed to squish those together because they don't have the exact same variable parts. However, these are both constants, so I can take 6 plus 12. And so that's what we have for our solution. There's 3 parts to it. We've evaluated this expression, okay? And we've combined the like terms. Let's just do one more, and in fact, this is a good review for multiplication. So I'm going to take 8 times both parts and 5 times both parts. 8 times 1/2 x. You know what, better yet, let's just review this one when I see you again. And we'll be able to explain how the fractions work a little better than in this video, and it'll be a good review to start class. So I will finish these in class when I see you again. So that's it for today.